As far as hazards are concerned, the biggest risk to commercial tire service technicians is the process that pressurizes tires during service and maintenance. That's why OSHA has specific requirements for the equipment that must be used to inflate truck tires. The first component is a clip-on air chuck. A clip-on air chuck is a device that temporarily attaches itself to a valve stem so the compressed air system can pressurize the tire. Clip-on chucks are not to be confused with air chucks that screw on the threads of a valve stem or valve part. The second component is an inline valve with a pressure gauge or presettable regulator. The inline valve with a pressure gauge is a traditional tire inflator where the technician must press a button or lever to inflate the tire. When the button or lever is released, the pressure gauge will automatically show the inflation pressure. A presettable regulator is a standard regulator set to the recommended pressure for the tire being inflated. This ensures that the tire cannot be accidentally overinflated on an unregulated line. The final component for an OSHA-compliant inflation device is a sufficient length of hose to remain outside the trajectory at all times. The trajectory is any potential path or route that a rim component or air blast might travel in the event of a separation. Technicians should never inflate a tire when standing in the trajectory of the sidewall. The best place to stand when inflating a truck tire is even with the tread. If the technician can see or read the sidewall during the inflation process, then another position must be selected or a longer inflation hose must be used. According to 1910.177, single-piece assemblies must be placed in a restraining device, positioned behind a barrier, or bolted to the vehicle during inflation. In order to comply with OSHA regulations and industry guidelines, all used, retreaded, or repaired tires must be inflated in a restraining device. While it may be considered acceptable to inflate a new tubeless tire on a single-piece rim after it has been bolted to a vehicle, the best practice is to inflate all truck tires in a restraining device. During the single-piece inflation process, there are two primary hazards that technicians must understand: heat-damaged rims and zipper ruptures. In most cases, a heat-damaged rim is an aluminum wheel that has been operated in an overloaded condition for an extended period of time. The combination of heat and additional weight causes the rim diameter opposite the disc to become smaller. A ball tape may indicate just a few millimeters difference, but it's enough to cause a serious accident. When the rim diameter is reduced, the bead is eventually forced over the rim flange. Since the tire is pressurized when it slips over the flange, it results in a violent separation. Even when the tire is contained within a restraining device, the release of pressure and energy is still enough to cause a serious or fatal injury. Zipper ruptures occur when overflexing in the sidewall of a radial truck tire causes damage to the steel sidewall cables. On this X-ray, the damage is evident on the individual wires on each cable, but the cables as a whole remain intact. When the cables break during the inflation process, they produce an audible popping sound and a noticeable bulge on the sidewall. Eventually, the pressure becomes too great, and a circumferential break in the sidewall allows all of the pressurized air to spontaneously release at a random spot. The unpredictability of the pressure and location of the rupture is what makes the zipper rupture particularly hazardous to technicians. Like the heat damage separation, the tremendous force of the pressurized air is enough to cause a serious or fatal injury. So technicians must remain outside the trajectory throughout the inflation process. According to Tire Information Service Bulletin Volume 33, Number 3 from the Rubber Manufacturers Association, or RMA, all truck, bus, and light truck tires with steel cord radial construction are potential zipper rupture candidates. Truck and bus tires are defined by the RMA as having a load range F or higher, and light truck tires are defined as load range E or lower. In all cases, the radial tire will have steel cord sidewall construction. The first step in the inflation process is to seat the beads. In order to help center the tire on the rim, the best practice is to position the assembly lying flat with the rim suspended so the bottom bead is partially seated. Bead seating stands make the process easier and more efficient. Pressurize the bead seating tool and attach the clip-on air chuck and inflation device to the valve stem with the valve core removed. Use the quick release valve on the bead seating tool to partially seat the beads before inflating the tire to 5 psi. Install a valve cap on the valve stem before removing the assembly from the bead seating stand. The next step is to place the assembly in a restraining device that complies with OSHA standard 29 CFR 1910.177. With the valve core still removed, install an OSHA-compliant inflation device with a clip-on air chuck and stay out of the trajectory of the sidewall while inflating the tire to 20 psi. After the tire is inflated to 20 psi, inspect the beads to make sure they are seated. For all steel cord radial tires returning to service, including retreads and repairs, inspect the sidewalls for any bulges, undulations, or other irregularities that may indicate a zipper rupture. A grazing light or other type of indirect light will cause bulges and irregularities to produce shadows on the sidewall. If any of these conditions are present, the tire should be scrapped immediately. If none of these conditions are present, the tire should be inflated to operating pressure, which in this case is 90 psi. During the inflation process, technicians should always listen for any popping sound that may indicate broken cords. Due to the unpredictable nature of a zipper rupture, standing outside the trajectory throughout the inflation process is the best method for preventing a serious or fatal accident. The final zipper rupture inspection procedure is to overinflate the tire by 20 psi with the valve core still removed. Once again, listen for any popping sounds that may indicate broken body cords and remain outside the trajectory during the overinflation process. Do not exceed the maximum inflation pressure stamped on the rim. If no signs of a zipper rupture are present after inspection, deflate the tire to the recommended operating pressure and install the valve core before confirming the inflation pressure with a calibrated air gauge. The final step of the process is to install a self-sealing metal or inflate-through valve cap.